All right, so linear equations. Now, if you recall from last semester, linear equation looks like this. Here are some examples. Could be something like y equals, that's a y. 2x minus 5, that's linear. That's a linear equation, meaning that if I were to graph this, what kind of figure would be graphed? A line. Now, the thing that makes it linear is that if you look at the exponents of both x and y, what are those exponents? Y to the first, x to the first. Okay, so those are linear. So the fact that the exponents are both 1s makes it linear. Next class period, you're going to see something like this. Y equals x squared plus 3. That is not linear because the exponent of x is not 1. What's the exponent of x? 2. You're going to see next semester that this is called a quadratic equation or quadratic function. This is quadratic. And you're going to see next class period that the graph is a parabola. So you may remember the word parabola from not last semester, but maybe a previous course you may have had. Parabola, P-A-R-A-B-O-L-A. That's the graph. And you can see what it's going to look like next class period. But a linear equation or a linear function, the exponents of the variables are all what number? 1. And in this case, we have y by itself, but y doesn't always have to be by itself. You could have something like 2x minus 3y equals 6, something like that. That's still linear. It's linear because x and y are both being raised to what power? The first. You also saw last semester that x equals 3 is a linear equation. I'm not going to use the word function. You're going to see in this course that this right here is not a function. We haven't really talked about function yet. This is not a function, but it's still linear. It is still linear. It is still a linear equation. Even though you don't see a y, it's still a linear equation because because x is being raised to what power? 1, and the graph is still a line. Do you remember what kind of line this is? X equals 3? I know you had a Christmas vacation and all that. You had a lot of eggnogs. Huh? Oh, it's not a function. It's still a linear equation. It's still a linear equation. Do you remember what kind of line this is? Vertical. It's a vertical line. You're going to see again how to determine it's vertical. So you already forgot. And then y equal 3. Now that is a function. You'll see why it's a function in a little while. Not a little while, but we're going to talk about functions next class period. But it is a function. It's also linear because y is being raised to what power? 1. This is a function. Now don't worry about the idea of function yet. You're going to learn about that next class period. But for right now, know that this is a function. You have no idea what makes a graph a function or not. You can see that in the next class period. It is a function and it is linear. It is a linear equation. I'm using the word equation because what do you see in this expression? An equal sign. Now, do you remember what y equals 3 looks like? What? Someone said, horizontal. That's a horizontal line. Y equals 3 is a horizontal line. So you're going to see when we do this that this is a vertical line. And that's actually worksheet B. If you go to worksheet B, you'll see an x equal and a y equals. And this is a horizontal line. All right, so both of those are worksheet B's on worksheet B. Okay? All right, so let's start graphing linear equations. We're going to look at linear equations. We're going to look at the quadratic next class period. But for right now, we're just reviewing linear. This was from 10.2 last semester. This is 10.2 from last semester. Okay, so let's look at this example. Let's go ahead and graph All right, now in my math lab, there are two sections. There's a 10.2 and a 10.3. 10.3 talks about intercepts. And last semester you talked about intercepts as well, the x and y intercepts. In 10.2, we just use the t-table. Remember the t-table? So that's what we're going to use here. 10.3 are the intercepts, and that's where we talked about x and y intercepts. But for 10.2, we use a t-table, so let's look at this example. Let's go ahead and graph. This is going to be number 8 on page 738. All right, so here's number 8. You have y equals negative 5x plus 2. Negative 5x plus 2. All right, now remember to graph a line, how many points do you need? You must have a minimum of how many points to graph a line? 2. We always used how many though? 3, because you could have messed up on one of those other points. So if you did it correctly, all those points have to be collinear, meaning they have to lie in the same line. So let's just still use 3. So you have your x and a y. And remember, what was always the number that you use for x? The easiest number? 0. You always use 0 for x. So if x is 0, wherever you see the variable x, what did you plug in? And so remember what you did was you said, well, that's y equals negative 5 times x, and what's x here? Plus 2. And then you use the order of operations. I have multiplication, addition. What do I do first? Multiplication. Negative 5 times 0? 0 plus 2 is 2. So when x is 0, what's the y coordinate? 2. Okay, so when x is 0, my y coordinate is 2. All right. And then we picked another point. So give me another coordinate for x. Positive 1. All right, so when x is 1, I get y equals. So all I'm doing is just wherever you see the variable x, you're just plugging in what you're saying x is. So x is 1. So y equals negative 5 times 1 plus 2. You do multiplication before addition. So it's negative 5 times 1. And negative 5 plus 2 is? Negative 3. All right. And then let's go ahead and use a negative number for x. So let's say, now, whenever you pick numbers for x, always look at your grid. Make sure it fits on the grid. So always make sure that the coordinates used for x are somewhere in here and it fits in here. You don't want to plot a point that's way out here. Just try and make sure it's in here. So on the ones that the little grids that you picked up, if you use, let's say, the smaller one, I would use negative 5 for x, right? Now, if your grid was large enough, you could, because what's negative 5 times negative 5? And 25 plus 2 is, way out here, right? So I would say negative 1. Someone said negative 1. Negative 1. So if x is negative 1, notice what happens, though. You get y equals negative 5 times negative 1 plus 2. What's negative 5 times negative 1? Positive 5. 5 plus 2 is 7, and it still fits in here. Now, someone else could have chosen, let's say, 2. There's still enough room in there. You could have chosen 2. Negative 5 times 2 is what? Negative 10. And negative 10 plus 2 is negative 8. And it still fits in there, right? So there are a bunch of things. Now always use integers. Don't use decimals here, because then you have to approximate where it is on the grid. So notice we always, every time you did this, you always use an integer. 0, 1, 2, 3, negative 1, negative 2, negative 3, and so on. All right. And then what you did next was you just plotted those points. Now remember, these are ordered pairs that you're plotting. So on the worksheet, not on this one, but on part, isn't it? No, there's not even on this one. But on my math lab, it's probably going to ask you to list the ordered pair. So here's what I mean by an ordered pair. So when I use the word ordered pair, if I say, tell me what an ordered pair is that's on this graph, you're just going to say what your x and y is. So what's x here that I'm pointing to? 0. What's y? 2. But when you list it as a parentheses. So you can say 0, parentheses, 0, comma what? 2. That's an ordered pair. What's another ordered pair that's on here? 1, negative 3. You understand what I mean by ordered pair? So you have a pair of numbers, and then they're in order. X is listed first, y is listed next. Okay? That's what I mean by ordered pair. When we talk about intercepts, they're going to ask you to write the intercepts as an ordered pair. Right, so that's where that's going to come in as well. All right, all you do is just plot those points, and we're just going to use the first 3. And make sure they always lie in the same line. So when you plot the points, so this is number 8, y equals negative 5x plus 2. So 0, 2, remember how to plot 0, 2? Where do you always start? At the origin. At the origin, remember the word origin. You start at the origin. The origin is where the x and y axis intersect. So x is 0 here. So that means you go right, left, or you stay. Stay. My y coordinate is a positive 2. So that means I go up, down, or I stay. Go up. So 0, 2 is going to be on the y-axis, positive y-axis, so right here. Now, the direction says label, and I think it did. It says show the t-table and also label the points. All right, if it says label, what does that mean? You have to put the ordered pair. So this is the ordered pair 0, comma 2. That's what I mean by labeling. So those of you that didn't have me last semester, you know now what label means. All right, the next point we're going to put on here is 1, negative 3. So 1, negative 3 is in what quadrant? Let's see if you remember your quadrants. 1, negative 3 is in what quadrant? 4. So remember your quadrants go counterclockwise. So this is quadrant 1. This is quadrant 2, 3, 4. So 1, negative 3 is in quadrant 4. So you start the origin, go to the right one, and then what? Down 3. All right, and then you label 1, negative 3. And let's do one more. 1, negative 1, 7. So negative 1, 7 is in what quadrant? 2. Negative 1, 7. So I go to the left 1 and then up 7, right? And then you label. And then you use a straight edge. Use a straight edge, and then there's your line. Now remember, those points have to be collinear. So if they're not, one of those points is incorrect. But they have to lie in the same line. All right, and when you graph it, you remember you also have to put what here? Arrows. You have to put arrows. Okay, so that's the graph of this line. Now remember what I'm graphing. You see those points that we did in the t-table? Those points here? Are these the only points that's on this line that I have here? No. I just use those points to help me graph it. How many points are on this line? An infinite number. Any point that's shaded would be in this t-table. Okay? All right, let's look at, let's do one with a fraction in it. So let's do number 28. Number 28. So here's 28. All right, 28. Y equals, again, we have y by itself. Y equals 1/4 x plus 3. Y equals 1/4 x plus 3. All right, now again, y is by itself, so that's the easy kind when y is already by itself. We use a t-table. All right, again, the nice number to use for x is always 0. First thing you should always use is 0. So if x is 0, I get y equals 1/4 times 0 plus 3. And what's 1/4 times 0? And 0 plus 3 is 3. So I have the ordered pair 0, 3. So if I want to start plotting that point, I can. So 0, 3 is on the positive x-axis, positive y-axis. Make sure you label. All right, now we have a fraction for the coefficient of x. And remember that coefficient, you really don't need to know it for this, but that coefficient at some point, you learned that a coefficient was a slope. Remember the slope? Y equals mx plus b. But that's the slope. The slope here happens to be a fraction, right? The slope here was an integer, -5. Slope here is a fraction. So when the coefficient of x or the slope is a fraction, you want to be careful what numbers you use here. If you use 1, the problem is if you use 1, you're going to end up with a fraction. You have to say 1/4 times 1 is a fourth, 1/4 plus 3, figure out what that is, and then estimate where that is here. That's not what you want to do. If you recall, whenever, make things easy on yourself. You want to make it a little bit easier. Whenever this is a fraction, you want to pick numbers for x that are divisible by this denominator. Remember that? So what numbers are divisible by 4? 0. What else? 4. No, not 2. Let's think about 2. Let's think about 2. 1/4 times 2 is not a whole number. That's 1/2. You still have to kind of estimate where that is. So numbers divisible by 4 would have to be 4 or bigger. So 0 and then 4 or bigger. 4, -4, 8, -8, 12, -12, and so on, right? Okay. But again, you want to pick numbers here that are going to fit in here. So the only obvious one then would be what? 4 and -4. You could also use 8, couldn't you? Could you have used 8?
Yes.
Yeah, because what's 1/4 times 8?
2.
Very good. 2 plus 3 is 5. Okay. All right, let's do 4. So when x is 4, I get y equals 1/4 times 4 plus 3, right? What's the fourth of 4? 1. You agree?
Yes.
All right. 1 plus 3 is 4. That's 1. 1 plus 3 is 4. So I'll plot the point 4, 4, and I need one more just to make sure they all lie in the same line. You can use 8. 8 will work. 8 will be here, or you can use -4. It's up to you. What do you want to try? -4? Okay, so if x is -4, I get y equals 1/4 times -4 plus 3. All right, I got to remember some things now. What's 1/4 times a -4? -1. -1 plus 3 is 2. All right, so I got my 3 points. I plot those, label them, and draw the line. All right, so 4, 4 is in the first quadrant. It's right here. I didn't mean to put the ordered pair here. All right, and then -4, 2 is in the second quadrant. And then you just take a straight edge and draw your line. And just to kind of remind you something about next semester, you don't need it for this section, but just to remind you something about last semester, the slope was positive, right? 1/4. So remember, the slope is positive. What should the line do?
Go up.
It should rise, and it's rising here. Here, the slope is what kind of number? Negative. So what did the line do? It fell. It went down. Okay? All right. But you don't have to know this for this section or the next section. But you did have to know this last semester. Right, that was that one. Let's see. So far, that should help you with 1 and 2. And number 3. All right. Let's do something like number 4 for a moment. All right, so number 4, let's, I may have to do an example. All right, let's do this example. Let's write this example. All right, let's suppose we had 4y equals negative 3x plus 20. 4y equals negative 3x plus 20. Now, if you go back to the previous problems we did, what variable is always by itself? Y. Now here, y is not by itself. What is on this side? 4y. So if we want to get y by itself, what would have to do to both sides? Divide by 4. All right, so let's do that. Let's get y by itself. So if we divide the left side by 4 and the right side by 4, it kind of looks like this. Okay. Now, 4 divided by 4 is 1. 1 times y is y. Okay, now for this part, write them as two fractions. So I get negative 3x over 4, so that means negative 3/4 x, just like this. And then what's 20 divided by 4? 5. So you agree to get 5? Okay. That's what it is. So you divided both sides by 4 to get y by itself. And now that kind of looks like number 28. All right. Okay, let's do a t-table. An easy number to use for x is always 0. So if x is 0, I get y equals negative 3/4 times 0 plus 5. What's negative 3/4 times 0? 0 plus 5 is 5. So I'll plot the point 0, 5. And then give me another number for x. Be strategic. Don't use any. Don't give me a y value that's a fraction or a decimal. Just make them integers. So if I want the y values to be an integer, then I got to make sure x is divisible by what here? 4. All right. So give me a number divisible by 4. 4. So if x is 4. So if this was negative 3/5, then you would use what numbers? 5, negative 5, 10, negative 10. Okay. All right. So 0, 5 is here. All right, so 4, so if x is 4, I get y equals negative 3/4 times 4 plus 5, right? All right, now let's think. What's negative 3/4 times 4? It's just what? Negative 3, good. Negative 3 plus 5 is 2. So I'll plot the point for 2. And question is point. So I'm going to my plane, and I'm my coordinate plane. I'm going to apply the point 4, 2. That's here. And then let's do one more. Will negative 4 work? Yeah, still going to be within that range. So if x is negative 4, I get y equals negative 3/4 times a negative 4 plus 5, right? And remember, negative times a negative is a what? Positive. So what's a negative 3/4 times a negative 4, though? Positive 3. Good. Positive 3. And what's 3 plus 5? 8. So I plot the point. Negative 4, 8. And so negative 4, 8 is here. And then you use a straight edge because they are collinear. Those 3 points lie in the same line. And this is it. I'm not sure what this is right here. I think it just popped up. All right. Any questions? Now it is falling right. And what kind of slope is this? Negative 3/4. All right. So any question on first worksheet? Part A? All right, so that's part A. All right, so you know what to do with part A, right? Okay. And make sure you use the direction. It says show the t-table. Show the t-table just like we did. and then label the points in the graph. And it says label at least how many? 3. So you don't just put 2 in there, put 3. All right, let's look at part B. Part B, same thing, same idea, except let's look at number let's see. I'm trying to see if there's one like number 1. There's none. So I'll make this up. So this will be example. All right, so we're graphing this. So let's say we had y plus 4x equal negative 1. Y plus 4x equal negative 1. All right, now remember, if you go back to the previous problems, now remember that we use the t-table. So if you go back to the previous problems, what variable do we always get by itself? Y. And so last semester you did some work with getting y by itself. And remember, when you got y by itself, you don't have to know for these 2 sections we're doing, but that's called slope-intercept form, just to remind you. Slope-intercept form. That's what you learned last semester. And remember, slope-intercept form looked like this: y equals mx plus b. Remember that? Again, you don't have to really know this for this. But at some point in your course last semester, in one of the sections, you did talk about slope-intercept form. All right, so you're going to get y by itself, basically. So if I get y by itself, that means I got to get this term that I'm pointing to. What's this term right here? And bring it to the other side. So when I bring it to the other side, you see right now I'm adding 4x, so the opposite would be to do what? Subtract. And always, and remember, slope-intercept form, x was listed first, so when you bring it to the other side, put x first. So when I bring the other side, can you tell me what this is going to be? Y equals what? Minus 1. So negative 4x minus 1. You see that? You subtracted 4x, right? So you had this. You had y plus 4x equal negative 1. Then you subtracted 4x. And then you combine like terms. Remember, combine like terms? 4x and negative 4x is 0. So you get y equals. And then put the x first. That's negative 4x minus 1. Okay? Mm-hmm. Okay. All right, then the t-table. Once you get y by itself, do the t-table. What's a nice number to use for x? All right, so y equals negative 4 times 0 minus 1. What's negative 4 times 0? And what's 0 minus 1? Okay. So then you plot the point 0, negative 1. And give me another number for x. 2. Is that still going to fit? Yeah. 2 will fit. So if x is 2, I get y equals negative 4 times 2 minus 1. What's negative 4 times 2? And negative 8 minus 1 is a negative what? 9. Negative 9. All right, give me one more. Don't use 3, because 3 is not going to fit in here. Negative 1. So if x is negative 1, I got y equals negative 4 times negative 1 minus 1. What's negative 4 times negative 1? 4 minus 1 is 3. All right. So then I plot those ordered pairs. So I'm graphing this example, which was y plus 4x equal negative 1. And I'm plotting those 3 points. The first one was 0, negative 1. So that's on the negative y-axis. The other one was 2, negative 9. That's in the 4th quadrant. and negative 1, 3. Okay? And then you plot those points. Now remember the slope. What is the, once you get y by itself, can someone tell me what the slope is here? What's the slope? What number is it? Negative 4. Since the slope is negative, the line should be falling, right? Now again, you didn't have to know that for what we're doing here. All right, don't forget to draw your arrows though. And so there's the line. Okay. All right, let's look at number 6. So this is number 6. Number 6 looks like this. We have y equals 1/2 x. Oh, and just to kind of remind you something from last semester. So remember right here when we put in slope-intercept form, the coefficient of x is your slope. What was b called? Do you remember? The y-intercept. So that's why the graph would cross the y-axis. Okay, so I just want to remind you of something. So when I go back to this equation here, when I got y by itself, what is a y-intercept? Negative 1. So that's where the graph should cross the y-axis. And if you go to the graph, if I go to the graph, is that where it crosses the y-axis? Yeah. The other one was, this one was, I think it was y equals negative 3/4 x plus 5. I think that was this one. Yeah. So what's the y-intercept here? Is that where the graph crosses the y-axis? Yeah. So just to remind you about some things from last semester. Again, you didn't have to know this to do this. My math lab is not going to ask you about slope and y-intercepts for this section. You just use the t-table. That's all they want you to do. Use the t-table. Okay. So notice you don't see a y-intercept listed. You see that? But if it's not there, what number is that understood to be? Plus what? No, plus 1. Plus what? 0. 0. Again, you didn't have to know that here, but I just want to show you something. So use a t-table. What's a nice number to use for x? 0. So we see the variable x, I plug in 0. So I got y equals 1/2 times 0. What's 1/2 times 0? 0. So my y coordinate is what? 0. Do you remember what the ordered pair 0, 0 is in the plane? Is the origin. And so when she said that the y-intercept is 0, you're going to see when we graph it, it crosses the y-axis at 0, meaning the origin. Give me another number for x. Pick a nice number. 2. Numbers divisible by 2. So when x is 2, what's y equal 1/2 times 2? 1. Give me one more number for x. Negative 2. Okay. When x is negative 2, I get y equals 1/2 times negative 2. What's 1/2 times negative 2? Y'all agree? Okay. All right. So I'll plot those 3 points. Now, should the graph rise or fall? You think it should fall? Wait. Should this graph right here, should the graph be rising or falling? Be careful, guys. What's the slope? Slope is positive, right? 1/2. So the graph should be doing what? Rising. So when I plot those points, they better be rising. Y'all agree? Yeah. Okay. All right, so 0, 0 is the origin. 2, 1 is in the first quadrant. And negative 2, negative 1 is in the third quadrant. And notice that when I graph it, the line is rising. Okay? All right, any questions at this point? All right, now let's look at This is going to be number, all right, make this an example. Right, as an example, y equals -2. Y equals -2. Now y is by itself, but what don't you see here? You don't see the variable x. All you see is a y. Now when we saw an x and a y, when you did see an x and a y, just remember when you saw the x and a y, either your graph rose or it what? Fell. Either it rose or it fell when the x and the y was there. If you go back to all of them, you'll see that. If one of the variables is missing, but you're going to notice, what you're going to learn is that either it's horizontal or it's what? Vertical. That's what that means. All right, now let's see if you remember how we talked about this last semester. So this says, so still going to do the xy t-table. This says, though, that y is always going to equal what? -2. So that means in your y column, this is always going to be what? -2, no matter what x is. So if x is 0, what's y? -2. If x is 2, what's y? -2. If x is -5, what's y? -2. That's what that means. Y always equals -2 no matter what x is. So x can be anything you want. Y has to equal what? -2. So y must equal -2. Must always be -2. No matter what x is. And so when you graph it, when you graph those 3 points, you're going to notice that you're going to get what kind of line? Horizontal. So y equals a number is a horizontal line. So y equals a number is always going to be a horizontal line. So when I graph this, 0, -2, 2, -2, -5, -2. See they all lie in the horizontal line? Okay. All right, so you get a horizontal line when it's y equals, okay? And then let's do the one where x equals. Let's do this one. The same idea, you can use the same interpretation. So let's say x equal 4. All right, use a t-table. They want to use the t-table, so you got to show the t-table. This time, though, this says x always has to equal what? 4. So this means that x must always be 4, no matter what, and what should I say? No matter what y is. So if y is 3, what must x be? 4. If y is 2, what must x be? 4. If y is -1, what must x be? 4. That's what that means. X must always equal 4 no matter what y is. And so when you graph those 3 points, it's what kind of line? Vertical. Now notice, remember in the t-table and in all the other problems, we always let x be 0. Here's a situation where, is x ever going to be 0 here? No. X is always what? 4. Okay. All right, so then you plot those 3 points, and you can see you're going to get a vertical line. And that's part B. That's part B. Yeah, so when you graph this 4, 3, 4, 2, and then 4, negative 1. And then use a straight edge. Like you draw your arrows. And that's it. Okay? All right. So in terms of those two worksheets, you should now have enough information to do part A and part B. Okay? Any questions before we go on? All right, so notice the t-table. Notice what happens when you just get y by itself. Notice what happens when you get x by itself. Now, when you get y by itself, remember the idea of slope. You don't have to know that here. In the last course you did, there were some questions in your final exam that talked about slope-intercept form and all that. That's not in here. But you are going to see it again in next semester in college algebra, though. The idea of slope-intercept form. All right? Okay, so let me give you, now there's also one part of, remember 10.2, if you go back, also deals with that parabola I talked about, and there's another one called absolute value. We're going to do that next class period. All I want to do now is just talk about what you remember last semester in terms of, let's also graph it using intercepts. So there's going to be a 10.2 part C, which you're not going to get today, but we're going to do 10.3 part A. So that's the intercepts, that's the easy kind. So let me give you that one. So there's going to be 10.3 part A. All right, so this is 10.3, section 10.3. Talks about intercepts. Now, when graphing these, they're going to ask you to graph using the x and y intercept. All right, so basically, if I didn't do a very good job drawing this plane, but if your line does this right here, this is your line. Wherever the graph crosses the y-axis right here, that's called the what? The y-intercept. That's the y-intercept. The y-intercept is where the graph crosses the y-axis. This right here, where the graph crosses the x-axis, that's called the x-intercept. And no matter where you are on the x-axis, you'll notice that the y-coordinate is always what number? No. 0. That's all right. But you do notice that if this is -3, you say -3, 0, 2, 0, 3, 0, 4, 0. You agree? Okay. So what you learned last semester was that to find the x-intercept, you let y equal what? 0. That's what you did. So when we do these problems, you're going to see us, when we talk about finding the x-intercept, we're going to say where we see the variable y, we're going to plug in what? 0. So if you look at the y-intercept, though, if I look at this y-axis right here, at any point on this y-axis, if I look at any of these points, what do you notice about the x-coordinate? The x-coordinate is what? 0. No matter where you're on the x-axis, on the y-axis, the x-coordinate is 0. 0, 1, 0, 2, 0, 3, and so on, right? You agree? Yeah. All right. So what you learned last semester was that if you want to find the y-intercept, you let x equal 0. That's what you did. Okay? So when we do the problems, it's very easy. You're just going to say to find the x-intercept, let y equal 0. To find the y-intercept, let x equal 0. Okay? So let's look at just one problem, and then we're going to finish this next class period. All right, so let's look at this example. Right, as an example. So let's suppose you want to graph, and you're going to graph this using intercepts now. So always read the direction. Direction says intercepts. Graph using intercepts. So in your final, there's always a question on the final, on the Math 99 final, that talks about graphing a linear equation using intercepts. You must use intercepts. Don't use the t-table. use intercepts. If it says intercepts, use intercepts. If it says use a t-table, use a t-table. But it's usually on the final, it's usually intercepts. So let's graph this using intercepts. So let's suppose we had negative 3x plus y equal 9. Negative 3x plus y equal 9.
Thank you.
Now, guys, remember in the last section you got y by itself? Don't do that here. Leave it as it is. Leave it as it is. Don't get y by itself. You're not using a t-table. You're just using intercepts. So here's the way you would do this. You would say, all right, if I want to find the x-intercept, I'm going to let what? Y equals 0. So in other words, the term that has y is 0. So this right here, see this term here? That's 0. So what equation's left? What do you see is left? You agree? And all you do is get x by itself. How do you get x by itself? Divide by negative 3. And so negative 3 divided by negative 3 is 1. 1 times x is x. And what's 9 divided by negative 3? Negative 3. So I found my x-intercept. So as an ordered pair, what is the answer for the x-intercept? Very good. Not 0, negative 3. It's what? Negative 3, 0. X is negative 3. What's y? 0. So you see what we did? All right, let's do the y-intercept this time. So to find the y-intercept, you're going to say let what? X equals 0. So if x is 0, that means that term that has x in it is 0. So that means that negative 3x becomes what? 0. So cover that term up, and then what equation do you see? And y is already by itself. So you found, see, there's no work for that one, right? Like there was some work for this one because you had to get x by itself. Here, y is already by itself. So now you found the ordered pair for that one. What's the ordered pair? 0, 9. And then all you do is plot those 2 points and graph your line. Okay? We're going to do more with this next class period, but let's just go ahead and graph these two. Plot those 2 points, I mean. All right, so when I plot those 2 points, so this is negative 3x plus y equals 9. So I get negative 3, 0 here, right? Label. And the other one was 0, 0, 9, so that's here. Oops, here. You agree? And that's it. Draw your line, and you're done. You understand what I mean by using x and y intercepts? You only see 2 points, and those 2 points are your intercepts. You see that? Not using 3 points. Don't want you to use intercepts. So there's an x-intercept and a y-intercept. Now, you're going to see next class period, here you see both an x and y-intercept, right? Okay. So next class period, you're going to notice that, well, there could be a situation where there's only one intercept. And you'll see that next class period. Okay. Now, in terms of this worksheet I gave you, Part C. Part A, I keep saying Part C. Do not mean to say that. You can do 1 and 2. I want you to try 1 and 2 before next class period. See if you can do those. You can actually do 4. And you may be able to do 3. But we're going to do one like 3 and 4 next class period because there's a negative y. See the 3x minus y? So I just want to remind you how to get y by itself when there's a negative in front of it. So I'll do one like 3 and 4 next class period. Okay? All right, but remember next class period we're also talking about that parabola. It's not difficult. Next semester you're going to learn a lot more about graphing parabolas. But this course, it's this very simple kind of graphing a parabola. All right, so